Hi everyone, my name is Milewski. I am Ceramic on GitHub, Twitter. I have a website, failuredriven.com, which I have not touched for 3 years. I am going to talk today about experimental methods in Sidekiq. For anyone who's an electronics enthusiast, all the hands go up. 1 or 2. There is a really good book. It's called Experimental Methods in RF Design. But we can talk about that later. We're going to talk about Sidekiq. We're going to keep going until you guys are really, really interested, and then I'm going to finish because otherwise I'll just keep going for too long. Who knows what Sidekiq is? Okay, we have a question. We have an answer here. Brendan, I'm actually happy you were here because at some point we're going to talk about K. Is that how it's pronounced?
I say Q, but apparently it's supposed to be K.
K.
I've said Q for too long.
And it doesn't run, so we could do a live coding. But would you like to tell us what Sidekiq is?
It's a job system for Ruby where it stores your jobs in threaders, and you have a job process. I think it can be part of Rails.
Yep.
Rails process.
So it does jobs. Does jobs. Cool. Let's go. This is going to be a very yes. He is. Mike Perham is from there. This is going to be, if anyone's seen my presentations before, every time I use a different slide system. This is slides, and about halfway through, we're going to throw it out. But let's see if I can even go next. Yes, I can. All right, I'm going to talk about other things than Sidekiq. But yes, Sidekiq is a thing. I'm hearing an echo. Sorry. Okay, so the other thing I'm going to kind of vaguely talk about this experimental method is around a couple of little things that I do that maybe will inspire you to do something similar. One, I like public Git. So I like to put all of my experiments out there on Git so people can have a look at them. And even in a workspace, we have like an internal where I work, an internal Git, which is called cooldown, and people just throw stuff in there. It means that if somebody came up with a cool idea or tried something, like other people can see that code and share it. So that's one thing, because I love sharing. The other thing, we're going to have a demo of this in a second, is a reproducible event stream as commit messages. So often I see a lot of shit commit messages, and I see here people that say, we've got the best commit messages in my company, should work for us. But what I'm going to show you is something somewhere in the middle, which I've found really useful. Well, okay, so according to this, I should be able to do Control E, will execute that line, and we'll open that up. Control E. Yeah, cool. And the second commit here, I think second commit in this. So this is what I mean by an event stream of in here. So the first line in a Git commit should generally tell you, if you applied this commit, what would happen? So set up, make file, and a presentation. Great. But often that's where we leave it. And then people go, well, where did all this stuff come from? Where does this setting file come from? So what I often like to do is stuff like this. I kind of describe in this case that you can now do make install, make present. You can do a Ruby, there's a missing thing in there. And let's say in this commit, for example, I'm using ASDF to manage my Ruby, and I wanted the latest and greatest Ruby. So if somebody said, how did you find that? You could go to this line and say, oh, you could do ASDF install Ruby grep for something beginning with a number, table last 5, and it will show you that at the point in time when I created this repo, the latest version was 3.2.0 preview 1. And that's the one I chose. And that's why I tore my hair out for the last 2 days. So that's what I mean, if I jump back to the presentation, by a reproducible event stream as commit messages. And I have used this over and over again, where people come to me and say, hey, how did you update this gem? And I go, oh, actually, if you go over here, not only was all this generated, but here's some of the commands that help me decide what to do. I find it useful. The other thing you may have seen there was the idea of what I said was a makefile. Who knows what a makefile is? Okay, who knows what a rake file is? Right, so everyone's hands almost go up for a rake file, because rake file is a Ruby makefile. And back in the day, in the 60s, you used to have need something to make your programs, to compile them. So somebody came up with make, and ever since probably the 70s, on every single Unix machine, you have make, which is really kind of interesting because what it allows you to do is run a couple of pre-made commands. Like you kind of just dictate what they are and they get saved. But whenever I show this to people, they go, oh, but I don't have make installed. I said, that's okay. You've got a Unix machine, you've got a Mac, you've got a Linux server with nothing on it. It has make. So demo, if I do Control E, it's going to run make inside of this repo. So Control E, and boom, we get a message of things, right? So my make file usually by default shows me the usage. What can I do with this thing? It also says, hi, Michael, welcome to experimental methods in Sidekiq. And it gives me these things and you go, oh, cool, I can show this message, or make install, we'll install all the things. Make clean, we'll clean up afterwards, and make demo, we'll probably run the demo. And the reason I do this is because so many projects I join and people say, oh, how do I install stuff? And they go, well, you know, if it's a Rails project, bin setup, right? And you run bin setup and it says, hey, you don't have this version of Ruby installed. And then you kind of go wonder how people installed that. So then people create scripts, and then maybe there's a seed file that you need to install at some point or something else. And I like a make file, one, because it keeps things relatively simple, like you can only do certain things with it. Two, it's available on every machine from the beginning. You don't have to install, I don't have to install Ruby to get Rake. I just have make. So you can fundamentally help bootstrap your project, and it's a really kind of handy thing. The other thing is it's part of a pattern. Patterns are good. Use it. There is a Three Musketeers pattern. In these slides, you could only execute all the code or no code at all. So I'm going to have to command click that. But yes, there is this thing called the Three Musketeers pattern, and make is one of the things because it's a cross-platform build tool to test and build software. Three Musketeers pattern is Docker, Compose, and Make, or something like that. But anyway, when you go back to work and they say, what were the talks about? This guy talked about patterns. Great thing. Patterns are good, right? So make is going to run all the commands that I need for today's presentation that I'll have just forgotten how to run. So that's why it's handy. Cool. So Sidekiq, we said it is something that runs jobs or something like that. We don't exactly know what they are, but yes, it's got an ability to run background jobs. And in my view, if you're in Ruby, you probably start with Rails. And as soon as you start using Rails, you probably have a database and you think like, yep, we're set. Probably the next step after that would be background jobs and Sidekiq. And the reason is, well, somebody says, hey, I want to download this report. You don't want to hold on to that open connection on a web page to say, I'm just doing this really long query. You want to say, cool, we'll email you the report once it's done. So you would kick off a background job to generate that. Or you may want to have a welcome email. So when you sign up, it will say welcome, and you'll also get a welcome email. Or when you leave a cart unattended for 24 hours, you may say, hey, I want to email this person 24 hours time to say, are you still interested in that Volta XPA that you put into your cart? So you can actually, with a lot of these jobs, you can actually go and send them into to be scheduled at a particular time. So as soon as somebody creates a cart, you could say, cool, create a job to send in 24 hours, unless the cart is checked out, to send them a reminder. That's what jobs are used for. And all the places I've worked at, which are places like real estate, Bike Exchange now, Marketplace, Redbubble, Fresho, Black Box Co, and now Zepto, all of them fundamentally use Sidekiq for running their jobs, and they run lots and lots of jobs. Demo. This one I actually have to jump out into all my windows. So I said I've got this make thing. So I'm going to, over here, I think, make Sidekiq web. And this is going to know what to do to run Sidekiq as a web page. And it says, cool, it's listening on port 9292. And now it's kind of refreshing because something's probably looking at that. The other thing I actually want to run is make Sidekiq, which is actually going to run Sidekiq, which is probably bundle exec Sidekiq, but I can't remember. oh, right, concurrency 1 and all that stuff. That's all in my make file. So we're now running a job server in this window, top left, that's just sitting there waiting for jobs to come at it. And it's going to do them. I'm going to clear that window. So it's just clear. Down the bottom, I am going to do make demo. And if I tab, it will actually show me the make targets I could do. And I go, oh, long job. Okay, so we're going to do make demo long job. And this will actually tell me that you need a duration. So I'll go, oh, cool. Duration, what do we got? 45 seconds, right? And up the top, we can see up here that there's a job ID and something called a long running job is running. My program down here has finished. It's done. It's done because it's put it in the background. So it's a web page, etc. It's finished. And if I knew which window to be in, where is it? Here. Oh, cool. Oh, it's busy, right? So this is the front end for Sidekiq, Sidekiq 7, in case anyone hasn't seen it. And I'll keep reactions happening there. But here we can say the argument was 45, 31 seconds ago. This is polling every 2 seconds to see, hey, is this job working? Is it working? And if it works, our process job should go up to 108. And that would mean one more job has been processed. Busy, 45 seconds, 47, give or take, some shitty coding, nearly 51, like, you know, come on, live demo. Oh, okay, gone. And we are 108. So that's what a background job is. So basically in this case, I said, hey, I want this thing to do whatever it does. It happened to take 45 seconds, give or take. And it returned immediately because it knew the job server would run it later on. Any questions about what potentially a job server does? No? Yes. Anyone wanting to give an answer? So it depends. In this case, we're running Sidekiq for the jobs. Sidekiq uses Redis for its data store. Redis is a relatively good key value store. There are ways of running Redis with, I think, replication and abilities to save stuff. So yes, I could actually kill my Sidekiq server as long as my Redis is still alive. Then it knows what jobs need to be run. But great segue, because that's what this talk is all about. What happens when Redis crashes? That's what we're going to try and work out. Now, somewhere in here, I have a window. Cool. So we know what Sidekiq does. Run some jobs. There's a web interface, some make stuff that Michael did, and where does the data get stored and what happens? So let's imagine a basic example you may want in a web app. Let's create a user. So you might do something like this. You may say, hey, user, create Mike, and send them an email. And you go, cool, that's robust, let's ship it, right? Yeah, it'll work. And then this is where I forget what's in the presentation. Oh, right, yeah, so we might want to do that. And then we kind of go, okay, great. We don't necessarily want to slow down the user via sending them an email, because we may have to reach out to an email server and tell them to send an email. Maybe we do some other stuff. So what we could do is create a job. So something along the lines of this. We have this module Sidekiq. And then inside of that, I kind of say, cool, we're going to create this user in a transaction. Oh, that's interesting. We're going to create the user. And then after everything's done, we're going to say, hey, cool, can you send an email after that? And there is obviously a couple of problems here. What if something crashes in here and in different parts of this code? So let's have a look. Oh, yes, like there. What if something dies in the transaction? So for those who don't know what transactions are, we've got a database. We need to write stuff into it. And most databases we use are what is known as ACID, which means they're atomic, and the other three acronyms. Right, who cares, right? The key one here is that it's atomic. So either the whole thing happened or it didn't happen. And if a failure happened in the middle of that, we will say, well, right, we should probably tell the user, but not create anything, which is good. And presumably at that point, the failure means you get kicked out of there, you don't send an email job. So that's probably okay, because the user will try and create themselves again. But what happens if a failure happens here? At which point we've created a user, but we still haven't sent an email. That user would never get the email. Now, why? There's various combinations here. You might say, well, what happens if we put this in here, et cetera, but for the moment, we're just going to say that this is a way to help simulate the potential kind of errors that could happen in our system. Even if things were written slightly different, we're kind of saying either the database failed to actually write the thing or the email did not get sent. This failure down here could be the one that was discussed previously. What if Redis went down, right? So we wrote the user, Redis went down, it lost everything in it, had a seg fault, and it says, right, I don't know what emails I have to send. Let's see what the next slide says. Right, who loves sequence diagrams? Yeah, and who likes, what are these ones called where they're like, is it a twiggle, wiggle, no, anyone? There's this thing, right, where you write this kind of code and it gets changed to a sequence diagram. Mermaid, yeah, twiggle, mermaid, same thing, right? So you can obviously read mermaid. If you can't, we're going to just jump out of the presentation into GitHub. And if there's one thing you take away from this talk, and it's not about GitHub commands or make files, it might be about mermaid. So in mermaid, that sequence diagram of create user execute changes into that. Is that really the same one, or in a state diagram? Yeah, or in a state diagram. It's that. Look at that. That is all, that piece of markdown gets changed into this. And if there's only one thing you take away from this presentation, star this repo, because it's got lots of these diagrams in there, and I spend a lot of time trying to work out how to do various things. And that's it. All right, next sure. So what have we got? A sequence diagram says there's kind of like actors, I suppose, and there's a timeline going down here. And we're saying, hey, this Sidekiq thing says, cool, I'm going to execute create user. And it says, cool, I'm going to do a create user. I'm going to wrap this in a transaction inside of Postgres database. So I'm going to begin, and I'm going to insert the user.create, it's going to get inserted. And if it succeeds, it's going to be committed. So Postgres is definitely there. And if it's committed, Sidekiq's going to go, cool, I can do the next thing. I can go and fire off, send an email job. And to your point, that gets written to Redis. And it sits in Redis. And then Sidekiq says, oh, I've got these jobs in Redis to do, so I'm going to do those. And we said, hey, there's two potential spots for failures. What happens if we break inside the transaction? No worries, Postgres saves that. What happens if we fail outside of the transactions? We potentially have what is known as, scroll up. Oh, we do a demo first. Oh, okay. What it's called is a dual write problem. There's a few links at the end of this presentation. You have two data stores, and you want to make sure something is in one and is in the other, and you got to make sure that you write to one and definitely the other, but only once, etc. And there's all sorts of issues that come around, but who cares? We're going to do demos. Demos are great. So I'm going to bring all of these things in. So this is showing us that we're running Sidekiq, right? It's ready to get some jobs. In here, we've got a database, and in this window, we're going to see what's inside the database. So that's the command that it's running. This is what's inside the database. Actually, this is really cool. If there's one thing you take away from this talk, if you're ever in like a test environment or a developer database, and you just say, just show me all the things. Active, record, base, descendants, map, all, map, throw me all the data out. You don't have to do this. You can just do map attributes, and it'll just spit out every single thing that's in there. Like it's just dump the database in Ruby. Great.
It even works nowadays.
Yeah. So we can see I have a user, don't worry about the outbox, and an email send table. And both of them are empty and empty. User, we have no users, email send, we have no email sends. We're not sending emails, we're just putting a record in the database to replicate that. So we know it's empty. And then down here, we're going to play a game. Somebody yell out their name.
Michael.
Nick. I heard a Nick. Nick. Oh, Nick Wolf. Maybe we do Nick Wolf. So I do make, and I want to create a user. So I say, oh, create user. And then I think I have to give it a name, and we'll say Nick. Only 4-letter names allowed. Nick, Mike, Mick. So what's going to happen? Well, if the code that I wrote makes any sense, this should say in a transaction, create a user, and then kick off a job, which we'll see in here. And when a job finishes, it will say that user has an email sent. So one other thing I need to check, because I don't know if I prepared, config app, no, sorry. Oh, right, YAML, config app, YAML. YAML. Cool, that's commented out. That's all that matters. Okay, so I'm going to create a user, Nick. I'm going to clear this. We're looking at the tables that are going to get created and go. We have a user. There, user created, no email sent. Job finished. And we have an email sent. Woo! Success, right? And this is what happens 99.99% of the time. Everyone's happy. The user got created. They got an email to give them their ORAL token or anything else. And I mean, this is kind of interesting as you walk into some of these error scenarios. Who's used the new scooters, the Lime scooters, or Neurons, Limes? GoGet. I've got a GoGet car, right? So I go up to the GoGet car and it kind of, it's on the map and it says, oh, the car's here. And I go, cool, I want to book it. And I walk down there and then I kind of like, the car's not there. No, the car's there. And I get my little swiper and I swipe it. Nothing happens. And I just go, I bet you that's just a job that just fell through. I swipe it again and it does it, right? With the scooters, it's the same thing. Had an issue, couldn't unlock the helmet. I want to, first time you ride them, you go, I better wear the helmet. So you press a button and it probably goes off because immediately the button changes. It says, yeah, all done. It's probably put on a Sidekiq queue. And some engineers twiddling their thumbs, dual right problem, lost that one. And your helmet's not unlocked. So you send it again, right? It's not the end of the world. But sometimes when you're in payments, as some of us are here from Zepto, it could be a problem. So Nick got created. That's cool. So what happens if we had an error? So I have this piece of clever code in here. Part 1 killer and die in part 2. So part 1 killer is going to prevent the actual user being written to the database. So it's just going to blow up the transaction. So if I save that, that gets reloaded. I'll clear that. And in here, we're going to create a user. It can't be Nick because it has to be unique. We'll do Mike. So what we're expecting to happen is I don't even know if this is creating a job to try and create a user. So what now happens is we see, hey, Mike hasn't been created, right? But something blew up over here. Something blew up in Sidekiq. So if we scroll down to the top of this big thing, we go, whoa, argument error, part 1 killer, right? So something blew up. And what we then note is in here, if we go to our Sidekiq instance, we go, oh, there's a retrying job. And we go in there and we go, oh, classic, the part 1 killer strikes again. So it can't create the user because right in the middle of that transaction, it's just saying, hey, inside the transaction, something went wrong. Like I couldn't save their avatar, their name was invalid, their email had a backslash, like that wouldn't happen. But it does. So part 1 killer kicked in, and what Sidekiq will do is retry, right? Which is kind of cool because maybe you're trying to connect to an external service or something else, and you go, oh, cool, it's going to retry. Also, sometimes this does happen where developers look at it and go, oh, that thing, yeah, we can fix that. Just change the bloody email not to have the umlaut in there or whatever. So in this case, I am that developer. I go in here, I go, oh yeah, we should get rid of that. So now we're going to have a job 2 killer. So this should mean the transaction finishes, Mike gets created in the database, but the email before it sends, Redis crashed. Segmentation fault, couldn't connect to some other server. It just died, right? So if I save that, that will have reloaded. We can clear that. We still only have Nick. We can go in here and say, hey, this is, next retry just now. And it retried because we got up here, we've got an error. We've got die in part 2 error, no longer in part 1. Over here, we see the user has been created. Mike's there, Nick's there. Nick, user ID 1, has an email. Mike, user ID 5, does not. And we go, whoa, hang on. Well, clearly there's going to be a job there for this. If I let this refresh. Yeah. Right. So this is now I'm confused completely. So it says, hey, this is part 2 killer. Where was the register bit? Oh, right. And this comes over and this is going to retry, but this is trying to create a user Mike. So when this retries, what's going to happen is it's going to try and say, hey, I'll try to create user Mike, but we're in an inconsistent state between our data stores. So in user Mike, it will say, whoa, you can't create one of those because Mike's already taken. We have that user. So it's actually going to fail. See how this failed job is sitting on 70? I think it's going to fail. So let's retry all now. Okay, boom, success. Poll, 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 and hoping. Of course I did. So we still don't have the email. Oh, it went into processed. It didn't get failed. No, here, because we got an error. So we got a particular kind of error that the way Sidekiq is set up by default, it says, oh, that's a user error. You can't create one of those. That's fine. I'm not going to retry. So you can set the kinds of errors that Sidekiq retries on. And I'm not going to retry on that because clearly that user already exists. Like, why would I create the user when they've already exist? But what happened was we had this scenario where we tried to do the Sidekiq thing straight afterwards. Something died. The user now and the job has succeeded, but they haven't got their email, or they haven't got their shopping cart email, or they haven't got their pay, or they haven't got their bonus points, or whatever you put into the job. So there is a problem when you create code. Where is our presentation? Somewhere in here. When you create code like this, we've got this transaction to create a user, and then you process the email job afterwards. So we've demoed the Sidekiq thing. So this is what I mentioned, a dual write problem. There's a couple of links there, 2 data sources, in this case, PostgreSQL and Redis. So you might be thinking, well, what if we stored everything in Postgres? And that is what is known as the transactional outbox pattern. So what's happened here? Sidekiq says execute. Execute says, cool, I'll begin. Create, insert the user, and insert the promise in the outbox to say, send that user an email, and then commit. And if this succeeds, then a job comes around later on and says, send the user an email, and it says, cool, I know I have to send that user an email. If this fails, the whole thing gets rolled back, no user gets created, no email gets sent, and the user is either told to try again or the job tries again because there's an internal error, which means this failure, the second failure that put us in an inconsistent state would never happen, because the only thing we have to do is have a dumb job that just says, is there anything in our outbox that I need to process? So let's demo that. Yeah, cool. So we have Sidekiq running. We have the database running. We may want to clean it. So I do make DB reset. Boom, that trashes it, regenerates it, reruns the migration, and we're in a clean set. So we've got a clean database up here. And if one thing you take out of this talk, make files are really, really good at running regular scripts, right? Because I don't know what I did there. I dumped the database, cleaned it out, deleted it, restarted it, migrated it, all of that in one command, DB reset. So now what we want to do, same, we want to have our 2 errors, but we want to use this outbox pattern. So I save that. I go in here and I do a create user. Who wants to go? Whose name? Gus. And we use outbox and we use Gus. So this should, I have no idea. Let's go. Let's see what happens. So this is using the outbox pattern. Which means this crashes. So Sidekiq crashes. It says, I can't do anything because presumably at the top of this, it will say we have failure 1, or something even worse. What is happening? Okay. Well, that's cool. I have no idea what happened there. Just succeeded. That's even better. Oh, because we had no failures, right? Because I uncommented the failures. No one picked that up. Okay, that means this is almost the last demo because we're running out of steam. Right, so I had no failures. Everything worked. The job succeeded. We forgot to see what happened in here. So let's quickly do it again. So we're going to do not Gus, right? So not Gus is going to get created. So we're hoping the outbox gets, the outbox says, hey, I want to create this user and send them an email. The user gets created and then both users get an email sent. So because it's in a transaction, the user and the outbox thing sits together, which means if we now take that out and see how that's really busy there, we can do that make command db reset. That will clear our database, get us counting from 1 again. Boom. And that means we can create Gus again. So it's going to fail on the first part, which means it should create a job, but it won't create the user or anything, I think. And I didn't clear the screen, so I can't. Right, well, we shouldn't probably be looking in there anyway. Yeah, I think we want to be looking in here. All right. Oh, we've got, that's because the card took to the server. Oh yeah, cool. So it's basically the outbox creating of Gus says argument error part 1, which means we didn't create anything. Everything's still waiting. So nothing got created. We don't know anything about it. We just know there's a job and that job's retrying. We're now going to let it succeed, but fail in the second part. So when it retries, retry all, okay. It's now dying in the second part, which means in here, what happens is we have a user Gus and we have the promise in the outbox to send that user model ID 13, send them an email. So what we had beforehand, where that was stored in Redis and Redis could have crashed at some, etc., is now in one database. So by putting it in one database in a transaction means we don't lose that. What happens though, so even though we don't lose that, our job, if I refresh, will have actually succeeded. Because the job says, hey, I've done my thing. I'm no longer crashing, I've finished. So over here, it says, it still gives you an error because when it retries, it says, hey, I've already created Gus. Actually, I don't understand why. But in this case, we haven't lost the fact we haven't sent this user an email because we know in the outbox that we've got that. And then we can have a dumb script. In this case, make db, like demo. Clear the outbox, right? So if I run clear the outbox, that will just go through and find anything in the outbox that hasn't been sent. And in this case, so cool, I needed to send that email or make that payment or et cetera, et cetera, et cetera. So if we go back to our presentation, we've demoed the outbox, which is this idea that everything's wrapped in a transaction because it's kind of in one data store. I'm going to call it time and questions because there is another thing, which is Q or K is the pronunciation, which actually does that for you. So it is a job server where it actually stores everything inside of the database. So when you say, I actually want this other job to send an email and then queue it, it just says, cool, I'll just do the whole thing in one transaction. So you actually get around the whole idea of the dual write problem. But you can use the transactional outbox. I'm going to call questions. Yes.
On Q, I guess what's its benefit over a delayed job, which has been around for a long time? Have you seen delayed job before? No.
Yes.
Yeah. What does Q bring to the table? This
So my understanding is Sidekiq brings performance and
also runs on top of Sidekiq.
so no, Sidekiq
Yeah.
is performance. Q, one of the things it gives you is this, the fact that it stores everything in the database. But potentially, if you got lots and lots of small jobs, which is the preference for jobs, you could also be thrashing and hitting your database a lot. I can't recall what delayed job does.
Yeah, I by default this is active record. So
Right. Okay.
Delayed job. Delayed job in Qbot store the list of jobs in the database, but they have a different mechanism for locking the jobs that are currently in progress. And Q uses a much lighter weight mechanism for doing that. Postgres is advisory locks, so it has much better throughput than delayed job.
Yeah, so protocol delayed job uses a column for it, like L1 IS and stuff like that.
I don't recall.
Yes, all lots of details. Igor, did you have anything to add, or basically that? Same. A hand up here.
I'm more a data person, so when you're talking about visualizing analysis, great for scraping. So sometimes scrape website, and I miss my data.
Yep. So what this gives you, if you are, so the question is this good for scraping? What this does give you is a couple of things. One, you can break down your problem into lots of workers. So currently I'm just running one worker, but on this machine, I could run 100 concurrent workers. So if I'm running a Ruby process to scrape something, I've got literally one process that says, go and fetch this site, do this. If I'm running this on Sidekiq, then I can say, cool, I want 100 of these, or I want 10 servers and each one to have 100 workers working. It also means when you hit a website and it's down or giving you an error, that will stay in that job queue and say, hey, I failed to screen scrape this. Should I try again? Should I tell you that there's an error? The other thing is there is add-ons to Sidekiq where you can actually have limiters on there to say, right, I'm only allowed to hit this site 25 times an hour or a minute or whatever it is. So you can implement that. I mean, there's nothing stopping you doing that at a programming level. So you could just say, hey, I'm going to have a Ruby script that's going to fire off separate threads and each one of them is going to do this. But at that point, you may actually be better off creating something that would run in a job server, whether it's Sidekiq, whether it's AWS Lambda, whether it's K, whatever you want. But that's some of the benefits of running it in a job. Any other questions?
You mentioned threads. Is it like multi-threaded? No.
It's multi-process is my understanding. So when I run, so in here I've got Sidekiq running. If I kill this and do a PSAUX and grep for, if there's one thing you take away from this talk, is that grep is a great tool. Grep for Sidekiq. And then, so yeah, AG is even better. So this will show us somewhere in here. I thought it tells you that it's running one of one in, here. So it's telling us, say, Sidekiq is running 0 of 1. So
and you pass concurrency, the concurrency number of threads. So
correct. So if I ran not a makefile bundle exec Sidekiq, I think by default in dev it runs 5. I have to tell it what to load. No. All right. This it has to require something rubbish. Minus R config environment. No, something like that. Load error. Oh, has to have a dot slash. Thanks, Sidekiq. So now, if I did this again, I know because it's 1 of 5 busy, right? So it's saying they're not busy. But yeah, to answer your question, it's not using threads; it's using processes. So that PSAUX would show more and more processes. If I ran with a -C, 20. So each one of those would be a potential process. So it's saying, hey, 0 of 20 are busy. And then if I said, well, let's create some long running jobs, long running job, right. So each one of those will be running in its own process. Right, so now it's saying 2 of 2 are busy, but
Actually, is that PS feature that what whole thing if it's
I'm 90% sure of threads, and there's another one that runs, like Perrin gives you another tool that will run
Okay.
multiple processes.
ignore the
Each
last
of
one.
which will run multiple threads.
Michael, otherwise, like in the process, each one. like,
Threads.
support,
Yeah.
it would be maybe like a 20 each.
You're all right. If there's one thing you take away from this talk, Michael is often wrong. But I'll admit it, right? Threads, it even says there, one process, 20 threads. Not gonna argue. You're right.
Question. How is this latest presentation tool compared to all the others?
It's really shit. So what I was using is slides, like you can brew install slides, and basically a markdown document gets changed into a slideshow, but it's in terminal. So I don't think, I mean, maybe in iTerm I could have an image in there, but obviously those graphs were pretty hard to read when they're not actual drawn mermaid pictures. So yeah, no, don't rate it. But I'll be back trying something new next time.
So how many key takeaways?
Oh, there's only ever one. If you're going to have one takeaway, come and check out failure-driven experimental methods in Sidekiq and give it a star. Like, let's see if we can star this thing. Whoa, look at that, 1 star. And if you do, I will tell you one thing though. If you really want to see mermaid in action, so we saw those ones, but then there's more, and there's look at these ones. They're like things backing onto themselves and all sorts of other things. There's a whole talk about sagas we're not going to do. It's bad enough that K doesn't work, and so just if there's one thing I'm going to leave you with, this talk, if I do make demo, oh, that's the whole fucking demo. Oh, Tmux is a great thing. Look at this. There's like this fired up windows everywhere. No, so I think I just want to run K, right? And it just bundle exec K, and it's tell me what is going on.
I'll slash.
Okay, third time lucky. These people on this Zoom call, get out. Where's the bottom of this thing? Yeah, give me a shortcut. No, don't pay for software. There you go. All the way. Oh, fresh show. I do have this running in another version. The thing that took me the longest was actually getting Sidekiq 7 running with strong migrations, which is, with standalone migration 7. And then those interfered with the version of rack they wanted because strong migrations needed rail ties, which needed a requirement on rack. And when I installed Q, that crapped out as well.
Are you using the non-Ruby 3 compatible version of Q on Ruby 3?
And I'm running Ruby. Yeah, probably. But the other version, again, had other issues with other things.
I'm sure Michael has like.
Yeah. Mind you, I'll give you an example, not now, but there is a scenario I had where Bundler took literally 10 minutes to try and work out dependencies. It just sat there going dot. No, I haven't got it yet.
I'm sure you can do that. Send it to Wonder or now. look at it.
So, in review, put it in Git and share it. Event stream as commit messages. Do it. A build script makefile will make it easier. And be careful if you have multiple data stores of the dual write problem. My name is Michael Milewski, ceramicfailuredriven.com. Thank you very much.